And then for our final module, the very last thing standing between you and actually sitting that 70-411 exam. For this final module, we talk about network access protection, which, as I've already said, is a technology that's been deprecated in Windows Server 2012 R2, and in all likelihood will not be available for any future version of the operating system. Network access protection on paper was actually a pretty slick idea that provided a way for you to ensure clients met a certain minimum requirement before they were ever allowed onto your network. With network access protection, you could set policies. Those policies could inventory clients as they were attempting to connect, and then identify if those clients had certain characteristics, like a firewall that was turned on, like Windows updates that were installed, or that an antivirus solution was installed and functioning. If any of these configurations were not appropriate or correctly configured on that client, well, network access protection, or NAP, would just simply not allow that client to access the production network. Clients that were disallowed from accessing the production network could be shuttled off into some remedial network where servers and services would exist that would help get them to the picture of health that your network requires. Now, Microsoft again has deprecated this solution, so it's one that we can't expect to see in future versions of the operating system. And you might wonder, well, why in the world would they get rid of a solution that could protect my network from clients that were inappropriately configured? One can make a few guesses as to why. For one guess, actually setting up network access protection can be somewhat complicated. There are a lot of moving parts that have to work perfectly in concert for this verification and possible relocation of incoming clients to occur. Also, NAP, kind of by definition, automatically shuts off any client that isn't appropriately configured. So if you don't configure it just correctly, you could end up in a situation where your worst clients are in now the worst possible situation for you to actually go about remediating them. Thirdly, Microsoft provides what is called an SHV, or a System Health Validator, to identify what characteristics you can be looking for on those clients. That default SHV, of which there is only one, was relatively generic in terms of what it's looking for. And so your definition of health, as opposed to what Microsoft's definition of health, could be very different things. And so without extreme levels of coding, or without going to some third party that in most cases never existed, you would never be able to really craft the very delicate situation or baseline configuration that you determine as your statement of health. And so the biggest result, the consolidation of all these facts, is that most organizations never looked at network access protection. Very few of them even attempt to get it set up and running. Its inclusion here in the 70-411 is here, and this is from Microsoft themselves, because NAP is still a part of the Windows operating system. Notwithstanding the fact that it's been deprecated, because it's part of the OS means it's part of the 70-411. And so for that reason, we're going to go through a very light look here at NAP, touching on the highlights of what you need to know in order to lay NAP into place. But more importantly, so that you're familiar with just some of the vocabulary and screens that it's possible you might see on the 411 exam. We here in this module will talk about the different system health validators, specifically the one that's available right out of the box, and the different settings that you can set, again, at a very high level, very coarse in terms of its granularity, for what defines a statement of health for those clients coming in. We will use those to define health policies, or very similar to the network policies we configured back in that last module, a further definition of what we consider to be healthy and what we should do if someone is not. We'll take a look at NAP enforcement using two different vectors. For the first, a machine that's attempting to get a DHCP address. For the second, a machine that's attempting to connect in through a VPN. Now, the first of these is a curious inclusion here because machines that attempt to get a DHCP address and that whole process of requesting a DHCP address is not really a great limiter on the part of the clients. Because any machine that can request a DHCP address can probably be easily reconfigured to just simply use a regular standard network address, a hard-coded one, if a person wants to get around your NAP enforcement. So DHCP NAP enforcement, although it's there, is something that is really not terrifically enforceable for anyone who has a clue what's going on. We'll talk also when a machine is considered to be unhealthy, how you can remand it to that remediation network and provide access to servers and services in that network to complete the remediation. This would be things like a domain controller that would supply group policy to turn on a firewall, a WSUS server to deploy Windows updates, or even some sort of antivirus server that could make sure that machine had the latest antivirus signatures. Again, with this, we'll kind of just wave our hands over the actual implementation of isolation and remediation, because doing this correctly, particularly in the VPN situation, requires servers and services that are accessible from the area where that machine's coming in from. That also adds some significant complexity towards how you might get this thing working in a production sense. And then lastly, we'll configure the NAP client itself, which exists on our Windows desktops. There on our little Windows 8.1 machine, we'll turn on that NAP client and take a look at the different ways in which your users can see whether their machine has been deemed healthy or not.